I take x plus y, I convert it to an equal, I solve for y, and I get that. Man. Going to my graph, I go up 6 on the y-axis, put a dot, and then from there I go down 1 over 1, and then down, I'll go down 1 over 1 again. And good thing I hit that point when I did that. That better happen or something's wrong, right? And I'm going to draw what through there? Solid, because it had the equal on here. So I'm going to draw a solid line right here. Let's take care of the shading right now. Well, I wonder if she's going to want you to shade both. Yeah. Yeah, let's shade. So what test point would you like? 0? 0? Does 0, 0 work into the first linear inequality? 0 is not bigger than 6, right? So this point does not work, which means I'm going to shade the outside of this. I'm going to do it very lightly, but I'm enough so that I know that it's shaded, right? And now I go through and I do the other line, the other linear inequality. Any questions? Good? The other one, 2x minus y is greater than or equal to 0, right? Sorry, change it to an equal. This is 2x equals y. Where's the y-intercept of this line? 0, right? So from that point 0, I'm going to go where? Using a slope of 2 over 1, so up 2 over 1, up 2, 1, 2 over 1, up 2, 1, 2 over 1 again. I hit that point. Good. That's a good sign. And then dashed, solid, what? Solid. Test point. Can we test 0, 0? Can't test 0, 0. What would happen if you tested 0, 0? It would actually turn out to be true, right? And then you come down here, you say shade that side, and then you go, oh shit, I'm on the line. Which side are you talking about? You see what I'm saying? So it wouldn't make any sense. All right, so let's test, what would be a safe point to test for this one? 2, 0, 1, 0. Could I do 0, 1? I could do that. I mean, so we have a bunch of options. But I heard, I don't know what I heard, 1, 0. And I'm plugging that into the second one. 2 times 1 minus 0, is that greater than or equal to 0? Yes? So this point right here that I tested, which was 1, 0, right there, that point worked, right? So I'm going to shade everything on this side of the blue line. Shade, shade, shade. Stop? No. Everything on this side of the blue line. Right? Everything. And now I'm ready for my final answer. I am going to come in here, I'm going to label this point so everyone knows what it was. It was the point 2, 4, right? And my answer is this solid, and everything over here shaded. And remember, it extends forever that direction. Understand this? No questions? Let's do one more. Oh, there's some language here. This is called a corner point. Okay, this is called a corner point. Makes sense that they would call that a corner point. This in here is what we call the feasible region. Feasible region. This is in your book, okay? One last one. See what we can do in the last 7 minutes. Feasible region. is all to this. So here's your last one. System of linear inequalities. Let's find the feasible region for 2x plus y is less than or equal to 22. X plus y less than or equal to 13. 2x plus 5y less than or equal to 50. And x greater than 0, y greater than 0. Greater than or equal to. Now this is more like a problem for this course. You have a system of linear inequalities. You actually have 1, 2, 3, 4, 5 of them, right? 5 of them. So we could do one, and then we could figure out if it's solid or dashed in shade, and then the next one solid dash shade, right? Solid dash shade, and do that for all these. When we had just 2 of them, right? What we did first was we found out where they hit each other, didn't we? And then we did the shading part. But what if we have, what, 5 of them? The recommended technique when you have this many, all right, is to graph all of them as lines first. Okay? Let's graph all of them as lines first. Now we will do solid or dashed depending on this when we graph the lines. So we're going to look at these all as lines. So all is equals first. Are we going to wind up dashing or solid for these? They're all going to be solid. But if this was changed, right, then that one would be dashed. All right, so let's do the first one. This one right here. You know, I'm going to do this a different way than solving for y. All right, here we go. If x is 0, what's y? 22. So if the x value is 0, y is 22. So let's say this is 10, this is 20. Oh shit, well, I'm going to have to go up to 50, maybe. No, I'll be all right. 20, here's 30. So do you agree that that point lies on this first line? 22, sorry. Here's 20, so 22. Agreed? That lies on the first line. And then if y is 0, what's x? 11. So that would be, let's say, 10, 20. So 11 would be here. We good? I'm going to draw a line through this. Solid line, because my inequality had the equals in there. I'm going to call this L1. And over here I'm going to label this L1. We okay with that?
Yeah.
Any questions?
Keep the 11 divided by 2.
20. I plugged in 0 for y. And then I solved for x, so I divided by 2. So remember, this point right here is actually the point 0, 22. And this is actually the point 10, 0, right? We plug in 0 for y, we get 10 for x. Here we plug in 0 for x, we get 22 for y. All right, next line. Do it the same way. Let's let y be 0. What's x? 13. 13 was to the right of this, correct?
Yeah.
Do you have a question? What?
Point is the one to the right of the chapter?
Should that be 11? Is that what you were saying? This should be 11. Yes, thank you. Is that why you were asking?
Sort of.
Okay, sorry. I put 10 there. My bad.
And where do you get 11 from?
Okay, 11, what I did is I replaced, because it's an x-intercept, you replace y with 0 here, so it kills this off, and you solve for x. So divide both sides by 2, and you get 11 on this side. Good? The other point you just said was what, 13, right? So this one right here is the point 13, 0. What about the y-intercept? So plug in x, 0 for x, get y is 13, which is about right here, roughly. Connect these with a solid line. L2. Y'all good? We got like 3 minutes. L3. You want to do L3? Let's do this one. Let's let y be 0. If y is 0, what's x? 25. 13. Same thing. Place y with 0, x is 13. Place x with 0, y is 13. Look, if you don't like the way I'm doing it, just solve for y and do it your standard way. Like slope, up, over. Okay, so what do we say here? If y was 0, x was 25. So that means we're up here. And if x is 0, y is what? 10. Jeez. Here. So like this. Is that okay? It's starting to look like a mess. L3. What is x bigger than 0? Or, yeah, what's that? Well, what is x equal 0? That's this, isn't it? So it's the y-axis? Yes. What did I do? Oh, I forgot to do, it's 5. Okay. I'm trying to rush. Okay, look, y is 0, x was 25. X is 0, y is 10. Oh, so this, y is 0, yes. Okay, good. No, it's important I get this right. I mean, I'm in here trying to show you, right? Okay, get this back. Y is 0, we're on the x-axis, right? So x is 25 out here. This is what you're trying to tell me. 25, 0. And then 10 over here. That's going to make this a lot nicer, actually. Okay. That's L3. Right? Oh, L4. L3. L3. There we go. Okay. Sorry, this is kind of a mess. And then x is bigger than 0. That's stuff to the right. Y is bigger than 0 or equal stuff up here. What's that? Well, now you'd have to see where they overlap. So, all of them. And also, see, I'm going to run out of time. You have to figure out where these points intersect also. Okay, so let me just look at this point right here. This would be the intersection of which two lines? L3 and, right, this is L3 and L2. So you L3 and L2. So what you would do is you would look at just L2 and L3, and you would go and solve that using elimination or substitution. That would give you this point. To do this one, what intersection is that? L1 and L3. Do you realize the amount of work here? Yes? Okay, this one right here. L1, L2. Is that right? So that's 3 different elimination problems that you have to do to figure out those points. Then you have to come in here and you have to go and test points for each of these to figure out which side you'd shade. And then you look at where they overlap. And because I'm out of time, I'll show you where they overlap. They overlap in this region right here. Now, Ms. Bradshaw will probably help you do this. Maybe you can tell her that I did example 2 on page 265 and that we just didn't get it all the way. And maybe she can help you figure out that that's the region, feasible region. All right, everyone. Sign-in sheet. Everyone signed in? Where is that thing? It's right there? Okay. Good day.